At this time, we want to discuss the subject of the origin of the universe. Now, of course, in any evolutionary continuum, you must explain where the universe came from, because you must have a universe in order to have a solar system. And you must have a solar system in order to have the Earth. And you must have the Earth where life could have evolved, you see. So everything must begin with some theory on the origin of the universe. Now, what we would like to do, first of all, is to review the nature of our universe, its immensity and its complexity. What is it that we must explain, either by some naturalistic, mechanistic, evolutionary process, or by the biblical proclamation, in the beginning, God created the heavens and the earth. A star is a very complex, improbable arrangement of matter. You know, if we'd bring a bottle of gas here into the auditorium and we would release that gas. Now, what would happen? Naturally, spontaneously, all by itself, where the gas would diffuse out evenly in all directions and eventually leave the building and diffuse out into space, and eventually, if we wait long enough, into intergalactic space. We know that's what happens naturally. We would not expect this gas to go over here into some corner and concentrate itself into a very dense ball at a very high temperature. We would not expect that to happen, now would we? And yet that's exactly what a star is. A very highly condensed form of matter at a very high temperature. Now when we take hundreds or thousands of these stars and put them in a cluster, that's an even more improbable arrangement of matter, much more complex arrangement of matter. Now when we take 100 billion of these stars and put them in the form of a galaxy, that's an even more improbable arrangement of matter. Here we see the Andromeda galaxy. Now we are told that there are about 100 billion galaxies in the universe, at least. Maybe there's many more, but at least that many galaxies in our universe. And we are told that there are probably about 100 billion stars in the form of a galaxy. Now, of course, to get all those 100 billion stars together in a galaxy, well, that's even very much more improbable, isn't it? Very much more difficult to imagine. And of course, we have different kinds of galaxies. We have the spiral galaxies. We have our own Milky Way galaxy, which, by the way, is a spiral galaxy. Now, you and I, we rarely see our own Milky Way galaxy today because we live in these big cities with all that light. If we'd get out into the country, deeply in the country, and look up, we'd see this marvelous Milky Way galaxy. Our sun is one of 100 billion stars in that Milky Way galaxy. Now, of course, if we look at the portion of our universe of which we are most familiar, that is the solar system. We have 9 planets in our solar system, at least that's how many we have discovered so far. And up to the present, we have discovered about 60 moons. We are discovering additional moons all the time. One of our recent discoveries of our space program was that Neptune has 8 moons rather than just 2. And recently, the 18th moon of Saturn has been discovered. Here we see Jupiter with 4 of its moons. These are called the Galilean moons because Galileo was able to visualize them with his crude telescope. And here we see Saturn with its marvelous system of rings. Here we have a closer view of those rings. And you know, those rings today are posing a very difficult problem for evolutionists. Now, evolutionists have suggested that everything in the solar system evolved about, now they say 4.5 to 5 billion years ago. That means that our sun and the planets and the moons and asteroids and comets and all that sort of thing came into existence all at the same time, some billions of years ago. But now they have discovered that these rings of Saturn have a very complex structure which could not be maintained for billions of years. So now they must imagine that Saturn evolved, maybe say 5 billion years ago, but these rings came into existence much, much more recently, and that's a very difficult problem in physics to try to imagine something like that. You know, our space program has produced problem after problem after problem for the evolutionists. They are always astounded when they get new information, where they see these anomalies and these difficulties, and you know, improbability piled upon improbability really equals impossibility, and that's what we've seen here in the results of our space program. Now, here's one of the moons of Saturn. This is Dione. Saturn, as I mentioned, has 18 moons. The smallest is one of about 12 miles in diameter, just recently discovered. Now, we see the planet Venus. Now, Venus is supposed to be the twin planet of our Earth. It's about the same size. And, you know, since evolutionists imagined that the solar system all evolved out of some homogeneous cloud of dust and gas, they, of course, expected and predicted that there'd be many similarities between the various planets in the solar system. What they have discovered is precisely the opposite. Each planet is uniquely different from all other planets. Take Venus, for example. I read an article just recently in which the author stated that practically everything about Venus is different than here on the Earth. Venus, for example, has a very dense atmosphere that consists mainly of carbon dioxide and with some sulfuric acid in its atmosphere. It has a surface temperature of about 750 degrees centigrade, while our own planet has a surface temperature of less than 20 degrees centigrade. And the amount of argon-36 on Venus is about 100 times what it is here on the Earth. Very unexpected result. And there are many other things like this that turned out to be so different from planet to planet that it's a great puzzler for the evolutionists. They just, you know, it's very difficult to imagine how all these unique conditions could have arisen from some homogeneous cloud of dust and gas. Now, we see that mysterious planet, that has been mysterious for centuries, the planet Mars. And people have long speculated there may have been, you know, maybe life on Mars. And here we see the surface of Mars. It's photographed from our lander that we put on Mars. Now, before we went to Mars, the evolutionists, most evolutionists that is, expected and predicted that we'd find life on Mars. They said, why, life has evolved here on the Earth under the conditions that existed here, and on the planet Mars there's an atmosphere. Now, it's a thin atmosphere, but there is an atmosphere there with the necessary gases, have all that energy coming in from the sun, so there's the requirements you see for life to evolve. And so they expected to find life on Mars, at least to find some evidence of the molecules that could lead to life or that had come from some living organism. And so they equipped that lander to examine the soil, and because Carl Sagan suggested there might even be big forms of life there on Mars, they mounted a video camera on the lander to make sure they didn't miss something walking around. Well, on the other hand, the creation scientists predicted they would find no trace of life on Mars. Now, when we landed on the surface of Mars, what did we find? Did we find what the evolutionists predicted and expected on the basis of their evolutionary theory? Or did we find what the creationists expected and predicted? Well, we found absolutely no evidence of life on Mars. No life whatsoever could be detected there on any scale whatsoever. They could not even find one single molecule, say of an amino acid or a sugar or something like that, would be the requirements for life. They found nothing. Now, you see, there's a complete failure of evolutionary prediction. There's a natural experiment. There are no scientists there or their apparatus to impose any artificial conditions, perfectly natural conditions. And we see the predictions based upon evolution and creation, and the predictions of the creationists, you see, were met explicitly, but complete failure of predictions based upon evolution theory. Now, of course, when I saw that first picture come back from Mars, I knew immediately there was no life on Mars. Why, if there'd been life on Mars, there'd be a great big sign up there saying, "Yankee, go home." Well, of course, our investigation was somewhat more sophisticated than that, but certainly no life was found there on Mars. Now, finally, we also explored the surface of the moon. And you remember what happened when our astronauts came back from the moon the first time? What did they do? They quarantined them. They kept them in isolation until they could test the soil, you see, to see if it contained some exotic organism, something that might spread some disease here on the earth. We had no resistance against that, you see. Well, it turned out those rocks are just as clean as any rocks could be. There's no organic material on the moon, nothing, no trace of anything like that. And of course, our astronauts had this marvelous view of our own planet. Now, how did all this happen? Where did it come from? How did it get here? Well, of course, there are those two theories, the theory of evolution and the theory of spatial creation. Now, according to evolutionists, well, I would say this, one of the more popular theories on the origin of the universe is called the Big Bang theory. Now, according to this theory, some billions of years ago, and they're not quite sure how many billions of years, they used to say 20 billion years, and not long ago they lost 10 billion years. But somewhere between 10 and 20 billion years, there was well, what they suggest is this, that some billions of years ago, all of the energy and matter in the universe was compressed into a huge cosmic egg, a plasma ball composed of subatomic particles and radiation. Now, nobody has the foggiest notion where the cosmic egg came from or how it got there. Someone suggested perhaps the cosmic chicken laid the cosmic egg. Well, I've never heard of a more scientific explanation than that yet. That's just as good as any. But in any case, there it was. And then for some equally strange reason, this cosmic egg exploded. And out of that explosion, essentially two things were generated: hydrogen gas and helium gas, the two lightest elements in the entire universe. Now, there was no nitrogen, there was no carbon, no sulfur, no uranium, nickel, lead, iron, or anything like that. Just hydrogen and helium, and mainly hydrogen. And these gases expanded out into the vast stretches of the universe. And that's all there was, hydrogen and helium. You might just as well say that the universe was hydrogen gas. Then somehow we are told from this highly dispersed gases, stars created themselves, and then galaxies created themselves, and our solar system created itself. Life evolved on this planet, and that first speck of life evolved into everything living and that has ever lived, including people. You and me. We have 30 trillion cells in our bodies of more than 200 varieties. We have 12 billion brain cells in our 3-pound human brain. And since each brain cell is connected to about 10,000 other brain cells, that means that in our human brain we have about 120 trillion connections. 120 trillion connections. The most complex arrangement of matter known throughout the universe. Now, what has happened? According to this theory, then we've gone from hydrogen gas to people. Someone has said if this is true, then we could say that hydrogen is an odorless, tasteless, invisible gas, which if given enough time becomes people. Well, that's what evolutionists believe, because you see, according to their theory, there was nothing but hydrogen gas then, and now there's people. So where did we come from? Ultimately, we came from hydrogen gas. I think it's incredible what an unbeliever must believe, you see, to be an unbeliever. It is really incredible, isn't it, what he must believe. As a scientist, I find that notion absolutely incredible, that anybody could believe that, but they do believe it. Well, of course, if that's true, then it has certain consequences. We make certain predictions about the nature of the universe. First of all, based upon this assumption that there was this big bang and these gases diffused out in all directions, The evolutionists predicted the universe would be homogeneous. That is, no matter which direction you look, if you look far enough, you'd see the same number of galaxies. The gases diffused out in all directions evenly, so the matter in the universe would be distributed evenly. It's called the cosmological principle, this idea that the universe must be homogeneous, equal distribution of matter in all directions. That is what they had predicted. That's one thing that they had predicted about the nature of the universe. Now, I want to come back to that in a moment, but first of all, I want to look at the thermodynamics of this origin of the universe. You see, if everything started as hydrogen gas billions of years ago, and this became more complicated, and all of this happened, and here we are today, people, then you see matter must have that ability. Wouldn't you expect, wouldn't you predict that matter would have some intrinsic ability or natural tendency to transform itself from disorder to order, from simple to complex? After all, we've gone from the chaos of the Big Bang to the cosmos. We've gone from the simplicity of hydrogen gas to the complexity of the human brain. Naturally, all by itself, spontaneously. So matter must have that tendency. Of course it must have that tendency. And we'll have some natural law today which describes such a natural tendency of matter. This tendency of matter to promote itself to higher and higher levels of complexity and organization. On the other hand, if creation is true, we'd not expect that at all, would we? If God created this universe, we would not expect that matter would have some natural tendency to promote itself upward to higher and higher levels of organization. We would not predict that at all. We'd not expect that. But if anything has happened since creation to change the original created state, and we know that it has, according to the scriptures, if something has happened since creation to change the initial created state, it could not promote matter upward. It could not cause matter to promote itself to higher and higher levels of organization. Could not do that. The only thing possible that could happen, it might cause matter to go downward. It might cause matter to go to lower levels of organization. You see, based upon creation, we might expect that matter would have a natural tendency to go from complex to simple, from order to disorder. That might be something that we creation would expect. All right? We have two predictions here then. Evolution says things went upward. Things are still going upward. We have that natural tendency, you see. While the creation said, no, the natural tendency would be this way. So we have diametrically opposed theories. Well, let's just go out there in the real world and let's take a look. Let's see what's going on out there. You know, that's all that science is. Science is just common experience. All scientists do, they just go out there and find out what's going on, then they try to explain it. So let's go out there and take a look. What do we find? First of all, there's no natural tendency for matter to promote itself to higher and higher levels of organization. No scientist has ever detected any natural tendency of matter to transform itself from disorder to order, from simple to complex. We don't see that happening. That's not a natural property of matter. Matter does not spontaneously do that. What we have seen is exactly the opposite tendency. All systems have a natural tendency to go from order to disorder, from complex to simple. That's what happens naturally, and that's what happens spontaneously, whether we're talking about the scale of the galaxies or down to the level of the molecule. Now I'm going to allow Dr. Isaac Asimov address this question of this tendency of matter. By the way, it's so universal, it's so all-prevailing, so unfailing, it's been formalized as a natural law, the second law of thermodynamics. What does Isaac Asimov, this man is an atheist, he's an evolutionist, a very strong anti-creationist. What does this scientist, this man who's written hundreds of books on science, what does he have to say about the second law of thermodynamics and what's going on in the universe today? Well, let's see what he has to say. This is what he has to say. This was published in the Smithsonian Institution Journal, June of 1970, on page 6. Isaac Asimov says this. He says, another way of stating the second law, then, is the universe is constantly getting more disorderly. Viewed that way, we can see the second law all about us. We have to work hard to straighten a room, but left to itself, it becomes dusty and musty, even if we never enter it. How difficult to maintain houses and machinery and our own bodies in perfect working order. How easy to let them deteriorate. In fact, all we have to do is nothing, and everything deteriorates, collapses, breaks down, wears out, all by itself. And that is what the second law is all about. End of quote. Now, it seems to me, if that's what the second law of thermodynamics is all about, the most well-established natural law known in science, evolution, is in trouble. Notice what he says. The entire universe is running down, it's wearing out, it's deteriorating, it's constantly becoming less and less orderly. You see, what is happening is this. Each star, our own sun, for example, is burning up, we are told, billions of tons of fuel every second. And that's true of every star throughout the universe. They are burning up their fuel. Now, it's obvious, is it not, that that fuel cannot last forever? You see, if there is no God, or if God would not intervene, this universe is certain to die. Because inevitably, someday, every star in this entire universe will have burned up its fuel. And if that should happen, the lights will go out. And there'll be no more activity. There'll be no life anywhere in the universe. Now, obviously, the universe will still be here, but it will be a dead universe. Now, that is a certain natural destiny of our universe if there is no God. Now, we know God will not permit that to happen. We know God will intervene. God is going to destroy the present heavens and the earth, as we read in 2 Peter chapter 3. And then he's going to recreate a new heavens and a new earth that will be governed by different natural laws than the present universe. But naturally, left to itself, that's a certain destiny of our universe. Now, this is a question with which I have challenged evolutionists time and time and time again, a challenge for which I have never received a rational answer. That is this. If the natural laws and natural processes which now govern the universe are leading inevitably to its death and destruction, and if, as evolutionists believe, these natural laws and natural processes are all there is and all there ever has been, how could they create the universe in the first place? Is it possible that the very natural processes that are now destroying the universe, could they have been responsible for its origin? What sort of tortured logic would one have to use to reach such an impossible conclusion? You see, the universe could not have created itself. The second law of thermodynamics, this law that tells us that there's this natural tendency for everything to run down, to become more random and less complex, that law, the second law of thermodynamics, applies without exception to an isolated system. Now, in the evolutionary view, the universe is an isolated system. Nobody did any work on it. Nobody brought in anything from the outside. Everything that took place within the universe and during its origin was a process of self-transformation. The second law of thermodynamics says such a system can never become more complex, more highly organized, more complex. Never. But it will inevitably, with time, run down and deteriorate and become less complex, more disorderly. Yet the evolutionists insist in believing that this universe is an isolated system, started in the chaos of the Big Bang, the simplicity of hydrogen gas, and transformed itself into the very, very complex universe that we have today. Clearly a violation of the second law of thermodynamics. It is irrational. It is unscientific to believe that this universe created itself. But it is rational. It is scientific to maintain that the universe cannot be an isolated system. There must be something external to it, therefore supernatural, that was responsible for its origin, you see. Now that's rational. That's scientific. Who is the scientist? Who are the rational thinkers? The evolutionists or the creationists? Certainly not the evolutionists, you see. Now, furthermore, as I mentioned earlier, the evolutionists predicted out of this Big Bang, we'd have a homogeneous, even distribution of matter throughout the universe. We have the cosmological principle that says our universe would be homogeneous. Everywhere you look, if you look far enough, you see the same number of galaxies. Now that was their prediction. Well, is that what we have in the universe today? Well, the evolutionists believe it must have been. And furthermore, when they discovered that background radiation, the 2.7 Kelvin background radiation that you see in all directions, wherever you look, you see this background radiation, supposed to be the leftover whisper from the Big Bang. They said that's the final proof of the Big Bang, you see, that cosmic egg exploded and spread out throughout the universe, and it would left over this leftover radiation. There we see it. And sure enough, everywhere we look, the background radiation is exactly the same, 2.7 degrees, no matter where you look. That means that the universe is homogeneous, just as we predicted. Everything fits. But when they finally were able to investigate out there in vast stretches of space and discovered what the real universe is like, the real universe is not homogeneous at all. The universe is very, very lumpy. Here's an article published in Science 81, the June issue of Science 81, on page 96 by Ben Petrusky. The title of the article, Why is the Cosmos Lumpy? The article reads like this: Few cosmologists today would dispute the view that our expanding universe began with a bang, a big hot bang, about 18 billion years ago. Paradoxically, no cosmologist could now tell you how the Big Bang, the explosion of a super-hot, super-dense atom, ultimately gave rise to galaxies, stars, and other cosmic lumps. As one sky scientist, IBM's Philip E. Seiden, put it, the standard Big Bang model does not give rise to lumpiness. That model assumes the universe started out as a globally smooth, homogeneous, expanding gas. If you apply the laws of physics to this model, you get a universe that is uniform, a cosmic vastness of evenly distributed atoms with no organization of any kind. No galaxies, no stars, no planets, no nothing. Needless to say, the night sky, dazzling in its lumps, clumps, and clusters, says otherwise. End of quote. Yes, indeed. As a matter of fact, since that article was published, they've discovered just how lumpy the universe really is. They have discovered, rather than the universe being homogeneous, they have discovered massive superclusters of galaxies, millions of galaxies in one single cluster, meaning that a very significant portion of the matter of the universe is there in that cluster. And in other portions of the universe, they found vast emptiness, vast voids in space. They discovered an area 300 million light years across where there wasn't even one single galaxy, just a great void in space. So we have, you see, a very clumpy universe, massive concentration of matter and great voids in space, precisely the opposite predicted on the basis of the Big Bang theory. Now, furthermore, if you have that very clumpy universe, then you might say the background radiation should be clumpy, that it should not be uniform. If you see that's the leftover remains of the Big Bang had to start out inhomogeneous, clumpy, and so the background radiation should not be the same in all directions. It should be more intense in certain areas of the sky and less intense in other areas of the sky. So they scanned the sky and they looked and looked, hoping to find some differences in that background radiation. They found absolutely no differences whatsoever. So they sent up COBE, this cosmic background explorer, a spacecraft up there in the sky with a telescope to check out the background radiation, hoping that they'd find some inhomogeneity, some difference. They found none. The background radiation, which is supposed to be the proof of the Big Bang, is going to be the death knell of the Big Bang. You see, what we have today, the real universe, does not conform to theory whatsoever. And how would you get galaxies? How would you get a star? How would you get those in the form of a galaxy? You know, they have no adequate theory whatsoever on galaxy formation. They have no adequate theory even on star formation. Here's an article, or it's taken from a book, The Sun and Stars by J.C. Brandt, published in 1966. This is what this astronomer says. Contemporary opinion on star formation holds that objects called protostars are formed as condensations from interstellar gas. This condensation process is very difficult theoretically, and no essential theoretical understanding can be claimed. In fact, some theoretical evidence argues strongly against the possibility of star formation. However, we know that stars exist, and we must do our best to account for them. Or as one other astronomer says, it'd be very easy to explain why stars didn't exist if they didn't exist. But they do exist, you see, and we must try to explain how they form. You see what this man is saying? We don't have any adequate theory. You know, the present theory on star formation suggested that stars form from interstellar gas and dust. Now, they've got to have this interstellar gas and dust in their theory on stellar evolution because you can't get stars from just plain hydrogen. So they have this interstellar gas and dust, and their theory is built around that. And as this astronomer says, even then they have a lousy theory. It really doesn't work. But they have to have interstellar gas and dust. Now, where does interstellar gas and dust come from? It comes from supernova. What do you have to have a supernova? You've got to have a star. So you see, in their theory, they have to have stars to make stars. And where do stars come from in the first place? They don't explain that at all. If you have to have interstellar gas and dust for your theory on stellar formation, stellar evolution, and that interstellar gas and dust comes only from supernova, and supernova come only from stars, then you have to have stars to make stars. You see, if they just start with hydrogen gas and helium, their theory doesn't work. You see, if you have this highly dispersed gas, and supposedly, according to their theory, and I remember from the Big Bang, this gas is racing out in a radial direction at enormous speed on all directions. Now, how in the world it ever screeched on the brakes and managed to collapse, I don't know. But anyhow, the theory is that from this highly dispersed hydrogen gas, by gravitational attraction, big, huge areas of this gas contracted to form stars. Now, there's some very serious problems with that theory because as the gas becomes more and more condensed, then it gets warmer and warmer and hotter and hotter. Now you have two forces at work. You have gravitational force pulling in, and you've got gas pressure pushing out. Now, astrophysicists have ways of doing this. They can calculate these two forces, the gravitational force pulling in, gas pressure pushing out. And when that is done, it turns out that the gas pressure pushing out exceeds the gravitational force pulling in by 50 to 100 times. Now, obviously, then a star will never form spontaneously because the gas pressure pushing out is vastly greater than the gravitational force pulling in. So these evolutionists then, they must search around, grasping for straws, trying to explain how stars form. And one astronomer, this is A.G.W. Cameron, in an article published in Scientific American in September 1975, suggested, well, he said, yes, it is true that gas pressure pushing out is greater than the gravitational force pulling in, and ordinarily the star would never form. But he said, maybe there's a nearby supernova, or perhaps there's some interstellar magnetic process or change of some kind that would provide the pressure and the push, and therefore the star would form. Well, again, what do you have to have supernova? You have to have stars, don't you? And if you're going to have interstellar magnetic events, you have to have stars. Again, you see, according to his theory, you have to have stars to make stars. He admitted that if you just start with hydrogen gas and helium, you can't get a star. You can't get it that way. But if you got another nearby star that explodes, maybe, somehow, that would give the necessary pressure. But that doesn't explain where the first stars came from. You see, they just don't have any way to explain the origin of stars in the beginning. Certainly, they cannot explain the origin of galaxies. And you know, just recently, they discovered a galaxy so far out on the edge of the universe. They believe that galaxy must have formed only about 1 billion years after the start of the Big Bang, after the Big Bang. That's their theory, you see. And they say that's not nearly long enough. Galaxies take billions of years to form. And that's a real problem for them. And you know what? When they have the ability to look right out on the edge of the universe, if we ever get our Hubble telescope to work, and maybe we'll be able to do that, at least what they believe to be the edge of the universe, you know what they're going to find? They're going to find galaxies right out on the edge of the universe. And that means those galaxies had to form instantaneously, and then they're going to be in real problem. Now, what about the formation of our solar system? Well, I've discussed that in some detail, but here's an article. This is, well, actually a book, The Earth, Its Origin, History, and Physical Constitution by Sir Harold Jeffreys, a famous British astronomer. This was published in 1970. He's discussing the origin of the solar system. You see, and have all the same problems. You got to form the sun, that is the star, you see, and got to form the planets and all that sort of thing, and everything else in our solar system. And Sir Harold Jeffreys is discussing all of these theories on the origin of the universe and the origin of our solar system. Then he says this. This is on page 359 of that book. He says, to sum up, I think that all suggested accounts of the origin of the solar system are subject to serious objections. The conclusion in the present state of the subject would be that the system cannot exist. Well, of course, it does exist, doesn't it? The solar system does exist. But you see, according to his theory, all of the theories, you can't get the solar system. It just doesn't work, so I guess it doesn't exist. We're not here, you see, but we are here, and the solar system exists. But you see, the solar system did not evolve. The theories on its formation, evolutionary theories, just won't work. But it does exist because God created it. And you know, these people are just playing at games. You know, most people believe that when they talk about the origin of the universe and the origin of planets, we think they're really top-notch, serious scientists. They're really discussing science. Now, none of those theories can be really scientific theories because, you see, there were no human beings there when the universe came into existence. There were no human observers. We didn't see what happened. Nobody saw what happened. And in science, you see, to be really scientific, to be able to construct a scientific theory, you must be able to see things happen, you see. You must be able to design experiments to test your theory and see what happened and make predictions. Can that be done in the origin of the universe? Not really, because we weren't there. We didn't see what happened. And you really can't repeat the origin of the universe today, can you? You can't do that. So what are these people doing? Well, let's hear what one of them has to say. George Abel. He says this, we are playing games. Cosmology is the best sport of all because it is the ultimate game. You see what he's saying? They're just playing games. Well, now, that's all right. That's okay for these people to play games. But if they let everybody know that they are playing games, and they have established the rule, you see. Their rules are that we must explain not only the operation of the universe according to natural laws, and we creation scientists agree with that. I mean, if we're going to explain the orbits of comets, if we are going to explain how the sun generates energy, if we are going to explain these various things and how living things operate and how they reproduce and so forth and develop, we use only natural laws and processes for that. How else can a scientist operate? Certainly, we believe that God created a lawful universe. He established the universe to operate according to certain natural laws. And as we try to explain these things, we utilize only natural laws and processes in doing so. But you see, the evolutionist goes beyond that. He steps outside of the limits of empirical science. He insists that we must not only use those natural laws and processes to explain the operation of the universe, but he insists we must use those very same natural laws and processes to explain the origin of the universe and the beginning of things, you see, and the origin of man and the origin of all living organisms. Now that's, you see, where we part company. And what he's doing here is not empirical science. These are things that nobody has observed or can observe. You can't repeat them today. You can't create a universe. You can't cause life to come into existence in the laboratory. You cannot test a theory how a fish may have evolved into an amphibian, you see. You can't do that. Therefore, these evolutionary theories are not scientific theories. Now, of course, creation and evolution have scientific characteristics. We can discuss them, as I have, in the light of the science of thermodynamics, in the view of probability laws, in the view of natural processes that are operating today. And as we look at the idea that life has evolved, we look at the fossil record and consider what it looks like, you see. Does it conform to creation or does it conform to evolution? We can do that. So creation and evolution have scientific characteristics. We can discuss them in scientific terms, but neither is a scientific theory. Creation and evolution are inferences based upon circumstantial evidence. And we see, therefore, that evolution is not a scientific theory, and the claims of evolutionists that we must restrict discussion of origins in the public school classroom based strictly on evolution is totally invalid. They are insisting, when we consider the origin of the universe, the origin of our solar system, the origin of life, that we think as atheists, that we consider only the possibility that this happened in a purely naturalistic, mechanistic means without any intervention of God or any supernatural being. Now that, of course, is totally invalid. As a matter of fact, most people in the United States are not atheists. They believe that God does exist, and if God exists, then creation is not only logical and plausible, it's inevitable, you see. But this is what these people insist. And what did Dr. Abel say? They're just playing games, but they've set the rules. They have established the rules, and they have excluded the very possibility of creation. They wouldn't even consider that. Why, if you exclude the possibility of supernatural creation, then of course evolution is certain to win. But we creation scientists insist that if you admit the possibility of creation, supernatural creation, evolution is certain to lose. Because, you see, it is contrary to even those natural laws and processes in which the evolutionists say they believe. Now, there are many other difficulties with this notion that the solar system and the universe evolved. They're finding many what they call anomalies. The meteorites, they've analyzed meteorites for the ratios of certain isotopes. It turns out to be very, very different than it is here on the Earth, and different than we find on other planets. There's all kinds of difficulties. Now, of course, any theory we would expect to have some difficulties, but as I mentioned earlier, improbability piled upon improbability is impossibility. The best conclusion, the best science today demonstrates that this universe is a manufactured article. It did not evolve from some homogeneous cloud of dust and gas. You know, the scripture tells us that the heavens declare the glory of God, and the firmament, that is the space of the heavens, shows the handiwork of God. And how that is true. So that none of us have any excuse. In the things that God has made, we can very clearly and easily discern certain unseen attributes of God. His divinity, his power, his creation. So that, the Bible tells us in Romans 1:20, nobody has a rag of excuse. And so we give honor to God as the master and creator of our universe. And to him we give that glory, that honor, and that position.